Okay, I'll just get started, and if we've got audio, that's good. Hi, as mentioned, my name's Adam. I'm a lecturer, used to be at UniSA. Technically, I still teach there, but UniSA no longer, well, SEMI no longer exists. So I'm now being employed by Adelaide University, whatever that entity may or may not be. I'm employed in the computer science department, what was computer science and has changed its name like 20 times since I started there. I like to think of myself as a token hacker. The university required one token hacker who they could just throw at any particular language, whatever they were doing, and it's my problem. So I don't specialize in anything at the university. I just program in absolutely anything they feel like doing. I'll do 5 or 6 different programming languages in a day, depending on what they make me go through. But my job is really there is to teach all of the weird subjects that I don't know who else can teach. I've been doing robotics for, well, 15 years, I think now. It's been a while. And in doing robotics, part of what you get into is obviously going to be Arduinos and microcontrollers and so on. So I moved through that cycle. I started with microcontrollers, and then I moved through ESP32s and Raspberry Pis and Orange Pis and I've got a couple of other weird things in here. So I've been through pretty much everything that exists by this point in terms. I've used PICs. I've used all of them at some point in robotics. So I've had a long history in it. Now, I should note that normally when I speak at university, it's good because I can, no matter what level it is, assume a general ignorance on the part of students. They may not agree, but I've never found myself to be wrong by assuming that ignorance. Sadly, I can't do that this time because some of you will know more than I do. So I'm going to tackle this as sort of a mix. So I'm mostly aiming at either at people who haven't programmed in microcontrollers before or have a background in Pis or Arduinos, but I've also had a lot of experience doing ESP32s. I'm really hoping someone's going to come up afterwards and tell me I'm wrong, because then I'll learn something and that'll be great. So we'll see how all that works out. All right, so just a bit of background. If you haven't seen one before, that's an ESP32. It is a very small, very simple chip. It is extremely cheap. I think Jeremy keeps telling me they're 15 cents or something if you buy them in bulk. They're not going to be very much. The normal way you see them is this, which is some sort of development board. There's a whole stack of different development boards out there for them. One of the things, and I'll talk about this later, that I hate is that every one of them has different pinouts and everything else is different, and they have to program them differently, and it's terrible. But that, as it may be, they're still moderately cool chips. So this cost me, this particular one I bought on Amazon, I think it was, what, $7? It's not a lot. It's an awful lot of processing power for $7. If you told me that I could get that back in my Commodore 64 days, I would have been overjoyed. I'll go through the specs in a second. So if you haven't worked with them before, you may go on a similar line. So the first one is you may have messed around with Unos and Arduinos. The Arduino is a deliberately underpowered CPU, and what it's really done over the years is it was intended to be consistent. So if you were programming with an Arduino, you would buy one of these and you would know that you could get like 3,000 different things to add to it, and they'd all be documented. And when a new model came out, guess what? It would use exactly the same 3,000 different things with exactly the same code as it went through the years. So the huge strength of the Arduino was that consistency. I could buy one for $5 from eBay that was imported from China and it would work just fine. I could buy one for $50 from Arduino, it would work just fine. There was just a wonderful consistency across the lifespan of them. I miss that now that I moved to ESP32s. But it's the strength of the Arduinos. So they're very consistent, easy to program. They do have a range of form factors. Some of them are stupid. I don't know if anyone here was dumb enough to play with the Lilies and the LilyPad Arduinos and so on. There were some weird things that came out over the years. But basically, we're looking at things like this. So these are ignoring the nanos and some of the smaller ones, an Uno, a Leonardo, and a Mega. And the nice thing is you can sort of tell that they've got a lot in common in terms of a layout. I can put the same thing that I make in any one of those. Mega gives me more power and more pins. Leonardo handles USB a bit differently amongst other changes. There's different CPU and so on, but they're all basically the same thing. Encoding is pretty straightforward. They don't have any Bluetooth, they've got no Wi-Fi, they have nothing wireless on them until very recently when the Arduino R4 showed up on the market. I've got 2014, absolutely wrong, 2024, it was last year when it turned up. I did pick one up, I hated it. So the way they did it is they stuck an ESP32 on it. which seemed a bit like cheating. And then on top of that, coding it is suddenly a horrible mess because ESP32 is a separate processor running on it as a co-processor, and it's just dumb. If you want to do ESP32 things, I reckon you buy an ESP32. If you want to do Arduino things, buy an Arduino. I don't see any need to stick an ESP32 on an Arduino. It's just a terrible, horrible thing. I could be wrong. I did buy it in 2024, so maybe it's better now. And if someone tells me it is, I'll be pleased to know that, but I'm not buying them anyway. So the R4 looks exactly like an Uno, by the way, a standard one. I've got some here I can show you later on. This is a Raspberry Pi. This is the other thing everyone uses. If you haven't tried a Raspberry Pi, they're stupidly fun. They're back in stock. Am I? Oops. They're back in stock. They're good. This is, I think, is this a 5? Yeah, I don't have a 5. I've got everything short of a 5, but I don't have one of them. The Raspberry Pi is fundamentally a computer. It's not a microcontroller. It's a full Linux computer. The way I picture them, if you haven't worked with them, is imagine you took your phone and you dumped the screen. And that's pretty much it. It's roughly the same sort of processor you would expect in a phone, an old phone now, but a phone. Roughly the same sort of memory. Runs Linux. Nothing stopping it running Android, I suppose. I've never tried. But it's basically the internals of a phone minus the screen that was sold very cheaply and is a lot of fun to play with. I do have issues with it. I'll come back to it. They do run Linux. It's not a microcontroller, but they did release a microcontroller recently in a Raspberry Pi Pico. Now, just to distinguish it, a microcontroller for our purposes is much simpler. It doesn't have an operating system. You program it pretty much directly. A lot simpler than what you get from a Pi, which is a genuine computer. These came onto the market not too long ago. They seem nice. They have certain advantages over an ESP32, but those advantages are not performance or memory, which is why I've tended to stay away from them. But there's nothing wrong with them. They're certainly fun. Until recently, they didn't have Wi-Fi. That was brought out with a Pico W, and they didn't have Bluetooth until very recently as well, when they introduced it to all of them. All right, and this is a thing called an ESP8286. I hate them, absolutely hate the things. If you want one, I've got a whole box of them. I'm very happy to hand them out because I don't know what else to do with them. So the ESP8286 is the version of the ESP32 that came out before the ESP32. So this is version 1. My problem with them is there's nothing actually wrong with them other than they're old. But when I go and order something on Amazon or I order it on Temu after drinking a little bit too much one night or something like that, there's a 50% chance I accidentally ordered another 20 8266s, and then I can't use them. So I end up getting this box of them because, what am I going to do with the things? There's nothing wrong with them. It's just that they're slightly lesser configuration. They don't have quite everything an ESP32 does. And given I'm paying almost the same amount as I would pay for an ESP32, I think there's a $2 difference. I can't see why I would bother getting them other than I'm drunk, Temu is horrible, and I've accidentally done it yet again. More often Amazon, to be honest, but that's okay. So yeah, it's basically an ESP32, no Bluetooth, less power. But it is $2 cheaper, if you care. It's not a big saving, but it's something to care about, I suppose. All right. Yep. It's an 8266, I think. But I can never remember the stupid number because I just hate them. So I know what an ESP32 is, and whenever I go online trying to work out what was this stupid thing that I bought again, I then have to ask ChatGPT or someone to remind me what the stupid number is for it. Because there's nothing wrong with them, as I said. They're actually very good. They're a good way to get started, which is, I'm not really trying to say they're awful because they're really good. And they were great when they came out, absolutely brilliant. But for me, if I can get twice the power for $2 more, I'm going for twice the power. All right, now you're not going to be able to see this very well, so my apologies, but I did want to do a brief comparison just to give you an idea of where all these sit, especially in terms of Arduino versus ESP32, and maybe the Picos. So just a couple of things to note. So if you were able to see it, one of the big differences is that ESP32 has a dual-core CPU. Makes a big difference, that one. The way it uses the core is also interesting. So by default, it will put all of your Bluetooth and Wi-Fi on the second core, which is handy as a programmer. It just means that I know what's going on. I don't have to worry about it. It's happening in real time, and it's not taking resources from what I'm actually trying to write. Other than that, we have the ESP8266, which is a single core, and the Uno, which is an 8-bit CPU traditionally, although again, they change it over time, so it depends on what you pick up. And the Pico is a dual core, just running at a slightly slower speed than the ESP32. So someone mentioned earlier that they use Picos instead. Perfectly good choice, just slightly lower clock speed and a couple of other differences sneak in. RAM, again, this is one of the big issues that I hit. So I used to love doing Arduinos, and one of the things I love doing Arduinos is controlling streams of LEDs. I have 2 rules when building robots. Number 1 is there is no such thing as too many lights on your robot. And number 2 is if it can't dance to single ladies, it wasn't worth making the damn robot. So I always follow those 2 rules. My problem is we now got to a point with our competition robots that we have to turn the lights out or we flatten the battery before the competition starts. I was really proud of that. That was a great moment when that started happening. But we also found that the Arduinos have a limit to how many lights they can control because there's only 2K of memory. So if I've got, a good standard array of 500 LEDs, it's going to get pissed off at me. So we did run into that memory limit. So to go from 2K to what was it? 520K? Yeah, that was happy. That was a good day. Then I can run as many lights as I like. So the ESP32s win there. And the other big difference is that the Picos are sitting around half that at 264K. So again, if you care about that and in terms of what you can do, you can program a bit more with an ESP32 than a Pico, and you can certainly program a lot more than you can get away with an Arduino. Opens up all sorts of interesting possibilities. Beyond that, I don't care about most of these. I'll mention Wi-Fi. So obviously, Arduinos don't come with it in standard unless you're stupid enough to buy an R4, although I shouldn't say that because I did, and they're probably okay. The main thing is you've got Wi-Fi and you've got Bluetooth, both classic and BLE, on the ESP32. So that's useful for a bunch of applications. Otherwise, operating system, none. I'm just doing this because Jeremy said he was going to try and trick me by asking what the operating system is on an ESP32. It doesn't have one. You just write directly to it. It's fine. So that's good. Now, this actually comes back to why I like them. So when I'm doing robots in particular and doing other sorts of small applications like collecting sensor data or whatever it might be, I want my computer to do just the job I told it to do. So when I'm working with an Arduino or an ESP32 or something like that, it's got nothing in the way. If I tell it to check every 10 microseconds, whatever it might be, it's going to do that check for me. It's going to run on exactly that speed. With a Raspberry Pi, it might just wander off to check to see if it needs to update anything. It does other things because I've got this operating system in the way. So it's why I so rarely use Pis. If I really need the power of a Pi, I'll put one in. But for the core systems, I'm always going to use microcontrollers because I trust them. I know exactly what they're going to do, and what they're going to do is exactly what I told them to do. So it's easy for them to convince me of their strength. Noting that the power consumption on all of these is very low. There is a small difference on an ESP32. If you start running Wi-Fi and so on, it's going to start sucking up a bit more power. But generally speaking, they're still pretty low. And I think that's, and cost. So I did mention there's a slight difference. So if you're buying one of these ESP8266s, generally about $6 each, I find it's got 2 to 6, but generally around that price to $10. If I'm buying an ESP32, generally it starts around $10, maybe 12, something in that sort of price range for a development board. If I'm buying where's the Pico? That's around $10, so around the same price, around the same sort of price as an ESP32, a bit more. Because they're branded, but not so bad. And then the Raspberry Pi, we're looking at a lot more, over $100, depending on the model. So, and Arduinos, I've got here $30 to $50 because I checked with ChatGPT, and ChatGPT does not know where I buy them from. So if I was paying $30 on Arduino, I made the mistake of going to JCar again. If I want an Arduino, this is what online is invented for. This is why eBay exists. This is why even Temu exists. And at $5 each, I don't care if I buy 20 of them and 5 or 6 are dud. It was still $5 each. So it tends to be the way I go with them. All right, so the ESP32 itself. So it came out in 2016, so it is actually old, well, 9 years old. As I mentioned, it's a dual-core RISC CPU. It's 32-bit. Main things, I looked up the model and then I thought, I don't care because I really don't understand these weird CPUs. If it said something like it runs an Atom, that means something to me. But it says it runs an Extensor LX6 or LX7, whatever that means. Fine. I don't care. All I care about is it's got dual core, it works fine, it's RISC. So that's the bit I'm worried about, and it's 32-bit. We've got pretty much everything we want to do for an interface. So your primary one, obviously, is going to be I2C. We also have SPI, which I use a fair bit on them lately. I love to CAN bus. I know that we sometimes, Jeremy and I, have some discussions about CAN buses. I adore CAN buses. They just suit me. It's got it built in. That made me so happy because I spent so long trying to work out how to get Arduinos hooked up to a CAN bus, and then I got an ESP32 and it said it's already built in, and that was it. I was sold from that moment on. You've got UART both through USB and normally as separate pins, and it can run software serial through pretty much any pins you like, which is nice. We have PWM, as you'd expect, digital I/O, ADC, DAC, everything you'd expect on one of these, they're all there. So in terms of interfacing, I have no trouble. I can interface with anything I feel like out of a set that it's got. For what, one thing to be aware of, if you're coming from the Arduino world, you're used to 5 volt for sensors. If you go to ESP32s, you've got to get used to 3.3 volt. Won't hurt you most of the time until you blow something up and the magic smoke gets out, and I've done it. Done it a fair bit, to be honest with you, but that's okay. That's what the magic smoke's for. You can never put it back in. Okay. Now, the result is that sometimes when I'm working with stuff that was designed with Arduinos more in mind, they do expect a 5 volt logic. It's really easy to fix. You buy yourself a logic level converter. I buy them in packs of 20 for about, I don't know, $10, $15 at a 20 from Amazon. Costs nothing. Wire them up and you're good. There is a 5 volt line coming from it because you're normally powering the ESP32 off 5 volts. But because of that, it's really easy to then to just take that line, run it through a logic converter, and we're set. We don't have any problems. Yep. Yep, powers off a USB without any problems at all. In fact, they always tell me it's never going to do much, and it seems to magically do a lot from the USB, so it's never bothered me. And I normally just hook it up to 5 volts, and there's normally 2 pins for V in, and it's easy. So technically, you can run 12 volts through it. And it will work, but I've never done it because I'm scared silly of a magic smoke, so I tend to stay clear of it. But I'm told it will survive 12 volts. All right, this is just showing you the pin out. I put this up there because it seems wonderfully impressive, all these magic pins. It also, if you can tell all the weird colors, it's magically confusing. I really love ChatGPT because it helps solve it. Every time I get confused about the pins again, I go to ChatGPT and say, okay, I thought I was supposed to use pin 12. What does that actually mean? And then I get told, no, that means pin 26, or some weird things going on with them. Now, I'll come back to this. The big problem is those pins are different on everything. I'll talk to you more about pins in a second when I actually get to an example. If you haven't worked with this before, it'll make magic sense once you see it. But each one of those represents something we can hook something to. So some of them might be for serial communication, some might be just so we can have a switch that it can detect when it gets pressed. Some of them might work for levels in a, let's say a very simple one. If you want to do a little ultrasonic to get distance, you could use a couple of those pins, one for trigger and one for receive, and it'll magically work. So all of those pins represent things that I can hook up to it. In practice, you'll find that there's a lot of them that are dedicated to something. So they're not always all there in practice to actually use. But that's the sort of strength of both the Arduinos and the Pis, and sorry, the ESPs, is that we can hook all these different devices up by using these little pins. And again, I'll come back to that in a sec. For wireless, which I think is probably more relevant to you, we have Wi-Fi, we have Bluetooth, and as I said, both classic and BLE, ESP Now and ESP Mesh. ESP Now is interesting. So if you haven't looked at it, I only recently discovered it, fell in love with it. I lost a good 2 weeks messing around with it because it was gorgeous. ESP Now uses the same basic thing as Wi-Fi, but it broadcasts. So what it means is that I can have my ESP32 send out a message to around and find out what other ESP32s exist and are listening. They can repeat back with their MAC address, and then I can start talking to them directly. It's low power, and one of the major things that I really like about it is ESP now can be still working while you're using Wi-Fi on the same device. So that means that I can have one ESP32 that's doing this, that's broadcasting to everybody and picking up data, and then I can connect to it over Wi-Fi and pull out that data and see it in a web page or whatever I want to do with it from there. So it's a really nice little thing that's unique to them. ESP Mesh is a mesh network if you're interested in working with it. It can be self-healing. It's got a lot of things going for it. Again, I haven't spent as much time on the mesh as I wanted to because sadly I got caught up on ESP now and just lost so much time on that, but I haven't got around to playing with ESP Mesh, but I will. At any point now, I will. All right, if you go outside of that, Zigbee and LoRa are both viable. I have had some experience with LoRa using both Arduinos and ESP32s, and I absolutely loved it. Okay, it's a stupid story, but I love stupid stories. I'm sorry. Many years ago, I was working on a robot boat. The boat was 17-foot catamaran that was supposed to compete in this competition in Sydney, and we had to program it to do various things. It's currently going flat out the back of a workshop at the moment, but I'll fix it very soon, I promise, and make it look attractive again. When we went to the competition, the one thing every single team competing failed at was that they couldn't do an emergency stop. They'd all tried to set one up, they all failed. We'd taken LoRa, and I think at the time it was an Arduino, but an ESP32 would do the same thing. I'd made 2 boxes. One box sent out a heartbeat, and then if it heard back within the next couple of seconds, it was good. And then I had a 15-kilometer range emergency stop that worked perfectly and took an afternoon to build. And every other team couldn't even get it to work. It was glorious. I love LoRa after that. It's the most wonderful little thing. So it's really very easy to work with. And again, all you need is a little thing to plug into it. And I think Jeremy's got something better for that. All right, so what do we do with them? If you're interested in programming them, you have 2 choices. You can program in C++ or you can program in C. Don't listen to the bit which says Python, because Python is an evil, horrible language that no one should ever be forced to program in. I just want to say, I'm a Perl programmer. Python is a horrible, evil language. No one should ever be forced to program it. Okay. So it's there. It's an option. MicroPython works very well with it. I haven't done it. I'm told earlier tonight that it does work really well. I believe it because, yeah, it probably would. And we have something weird called Platform IO that I haven't spent a lot of time in, but that's cool. Generally speaking, it's C++. Doesn't have to be, and there's a lot to be said if you're into that school of thought about MicroPython, but as I'm not, that's not really my thing. Easiest way to program is the Arduino IDE. I actually teach Python at university, so I try very hard not to express my opinion when I'm teaching it. There's nothing wrong with the language. It just forces me to indent, and I don't like being forced to indent. I want to choose to indent. I don't like a language making me do something. Sorry? Yeah, I hate Go. But I will always indent, but I want to make it my decision to indent. But anyway, that's a different issue. All right, so the easiest way is the Arduino IDE. So if you come from a background of using Arduinos and you've never done worked with an ESP32, you're going to use exactly the same tools. It's exactly the same environment. You download it for free. It always asks me to donate some money for it. I think by accident once I donated way too much money, so I'm never donating again. And then it's got all steps to go through. But once you get installed, and I'll show you in a minute because I've got it running on this, really, really easy to work with, very simple IDE, no problems with it, except that it's designed to support about 3,000 different boards, and you've got to pick the right one every time you plug something in, which is somewhat less pleasant than it might seem. Okay, but that one's fine. If you don't want to use the Arduino, you can use VS Code if there's any VS Code people here. Eclipse, for people who still remember Eclipse. I haven't used it for quite a while, but it's still out there. There is one from ESP IDF, which I did use, did seem nice, and then I just went back to Arduinos because I've been using the Arduino environment for 15 years now, and I didn't really want to leave it. So I just went back there and I still code there. But I do believe that they're probably better. And Thonny, if you want to do is one of the options for MicroPython. So you've got a bunch of different environments. I'm going to show you the code in a sec. So this is a basic hello world, but let's do it properly. So what I've got, I'm hoping this will work, is I grabbed an ESP32 lying around today. I discovered I'd already plugged it into this pretty green board. All that does is it makes it easier for me to access the pins. That's it. If you take it out of that, and don't worry too much, I know that I'm not showing people listening on thing, but that's okay because you're not seeing anything exciting. It's just going to be a simple little device with a bunch of pins. Sometimes I wire this directly in as it is. Lately, I've got to rather like these boards because, you know, for the immense investment of $5, I have a much easier time of wiring it up. That's it. No real problem. Just makes my life easy. What I have attached to that is a barometric pressure sensor. I went down to JCar earlier today to buy something. I saw that, thought I can program that. I've never programmed one of them before. That'll be great. So I picked it up for $5. Then got sidetracked by the giant 3D printer they had in the place. It was the most beautiful 3D printer I've ever seen. Did cause some problems because then I stayed there for another 20 minutes talking about it. But that's okay. So if you haven't worked with them before, again, this is the Arduino IDE. It's very simple. Major thing we've got to do is choose the correct device. So we need to specify the COM port, which you'll discover when you plug it in because it's the only one it's going to give you. And then you've got the hard bit. You've got to choose exactly which ESP32 development board you're using. And you'd think it would be easy. And I happen to know what this one is, so I put it in earlier hours of oh, come on, I thought I was plugged in. I'll just check to see why I'm not getting power. But that's right, we should survive to the end. All right, so if I go into here and I try to select it, I just want to show you the experience. So now I need to choose the board. It could be any of these. And my problem is that when you buy an ESP32, you probably don't know what the board is. I never know. So I look on the back and see if there's any hints. I ask ChatGPT to see if it knows. I just go through this cycle every single time to find out which one to pick. I just happen to know because I tried it earlier today and discovered that it had written on the back Node MCU, and I thought that's a pretty blatant hint. I'll type that in and see what happens, and it was there. So that was it. Once you get that out of the way, the rest is easy. When you're programming these, if you haven't done it before, the process is very simple. We have two basic functions. We have a setup function, which is a code that's going to run on launch, and we have a loop. The loop is going to keep on looping, as the name which suggests, for as long as you've got power after the setup. That's it. You can add whatever you like. You can add extra classes. You can add extra libraries. You can toss in anything you like from there, but that's basically all we need. Those two functions are the core part. In this case, function number one, setup, I have written serial.begin and then a serial speed. So I'm using the USB serial to connect to my laptop. And then the next one, because I still believe a hello world is the most important program you can write, I'm doing a hello world. I believe that. I try to explain this to students. If I can't get output, then what's the point of going any further? If I can't get at least something appearing on the screen, how do I know if my code works? And you know how often I've had students turn up with projects which I've never got to run and they think that I can market? It's just insane. If you at least can't get output, why are you even giving this to me? How do I market? So anyway, so here in this case, we've got hello world. That's it. We build it by hitting the magic button to upload it to the ESP32, which is hooked up via USB. It'll compile it, and it's a bit slower compared to Arduino's. There's more going on in the background. Eventually, it'll get there. And at the moment, I've got a serial monitor running in the other one, which is just going to show any output that shows up. The output is going to be really boring. It's going to say hello world. But, you know, at least it'll do that. Now, what I've also done, and this is to come to the pin set, so we'll let this run through. While it runs, so what I've done is I bought this new pressure sensor. I've never worked with it in my life. I've never tried it. I just thought I'd give it a shot because it was cheap, and it was, to be honest with you, the only interesting sensor JCar had left when I went in earlier today. So did a tiny bit of research, which took about 2 minutes to find out what library to use for it and what pins to go. So when I discussed the pins, I have 4 wires coming from my pressure sensor Two of those are power. I've got a ground and a V-in. In this case, this particular sensor can run on 5 volts because it's designed with Arduino in mind, but it supports 3.3 volts anyway because I know the chip that it's running needs 3.3 volts. So I'm running it off for 3.3 on the ESP32. I have 2 other wires. I looked it up. It told me where to plug them in. It said to plug them in, I think, to pin 23 and pin 21 or something like that. Not a problem. Plugged it in. Again, used that stupid chart I showed you earlier to get it running. By the way, here it goes. It said hello world. Yay. That other bit is just from boot. And there's my core message. Then what I did was I dropped in the library and I did the magic thing which everyone who does any programming with Arduinos will do. We grab an example. I'll see if I can find it. I haven't tried it on this computer, so I hope it's there. There it is. SPL06007 is the library. I'm dropping in pressure info. It's going to open a new window with all the code for me. From here, you'll see that there's nothing to it again. So it's including the library I want. Then down here, it's doing output like normal. And then it's initializing the connection to the pressure sensor. And then all I do is in my loop, or it's doing is in the loop, is it just asks for a whole stack of data from it and displays it, and that's it. Trivial bit of code. If I just wanted some of that data, I could delete the rest and I'd be pulling it in seconds. If I run this, and I did run it, oops, oh, is my poor computer angry at me? Ah, that's why. Okay, it'll come back in a minute. I'll have to do something to fix it. So I can go without it for a bit. You know what I did? I didn't plug it in right because I'm stupid. My plug was loose. So it'll have power in a second. We'll bring it back. But anyway, so the point is you run it and it's just going to give you a massive chunk of output as it goes through every one of the readings it picks up directly to serial. That's it. Now from here, we can do anything. So if we wanted to, from this point on, there is no trouble for us to say, hook it up to start broadcasting that. We could broadcast it or whatever we like, but the easiest method for me, if I wanted to mess around with this, is to drop a HTTP server on it, connect to it and just collect all that data anytime from that sensor, which could be sitting anywhere. And because of the lower power consumption, could be running off without any problem at all, just solar or something along those sorts of lines. But the entire job to get it to do that and to work with that sensor, I did it after we had our meeting. It took me 2 minutes. I was quite pleased. I thought that was relatively fast, even for ESP32s. It was just nothing. Mind you, as I said, all we're seeing here is the first run of it. So I'm not doing anything clever. I'm just pulling in data that somebody's already written for me based on code they've done. But because I've got that code, the next step is just rip it to pieces and pull the parts I want. And normally when we're programming them, that's what we're going to do. We're going to get test example code for each component we want and just combine them to make the thing we're actually after. Saves us all that difficulty of actually doing real programming. I wonder why this isn't coming back. Now we're coming back. I'll have it running in a sec. Yeah, students haven't. They have discovered ChatGPT. Which I like because they don't realize that ChatGPT is awful for programming. I don't know if you've used it yet, so I rely on ChatGPT a bit. I regard ChatGPT as a very poor quality junior programmer, one who can occasionally do something basic for me but works, but as soon as I ask it to do something clever, it's going to fall over and have some serious bugs in it. And then I get the joy of working out what the bugs are that it's giving me. So it speeds your programming process up, but you have to actually know what you're doing to get away with it with ChatGPT. For students don't know what they're doing, so they get this code which is just sort of, you can see that it was basically working, but there's some 3-year-old library that's been dropped in that I've never mentioned that's never going to work, or something like that comes in. And this is particularly the case when we start doing this with ESP32s. Just log in quickly. So that the hassle is that the ChatGPT is very, very bad at working with changing libraries and new languages. And so the ESP32 is still evolving so quickly, it'll recommend us some code for you. You plug it in and then you'll discover, no, that library is like 8 versions on now, and it's no longer compatible with those instructions. And then you point this out to ChatGPT and it says, yeah, you're right, that wouldn't work. And so it gives you some other code that won't work. And then you point out, so yes, you are so clever. That's absolutely true. That would never have worked. Here, try this. And then I just write it myself. Yep. But it's good for basic algorithms. Yeah, I'll bring that up. Let's see about Zoom. We're getting closer, though, to making this work, aren't we? After my stupidity. What I need to do is work out how to start up Chrome so I can get the Zoom link back. There it is. Oh, that was handy. Okay, join. Nope, no video, thank you. And no audio. Always something terrible is going to happen to the people at the other end. And let's share. Okay, we're back to working again, I hope. You getting the Zoom now?
Look, I've just come back now.
Oh, good. We are set. Okay, that was my own fault, by the way, just reminding everyone of that because I feel stupid. All right, so this should be able to build. We'll see what happens. Just wanted to pick up the thing plugged in because it's saying that's not there, but it should have detected it by now. Let's see if it builds. Anyway, if it builds, that'll be good. If not, we'll just move on. It built earlier, so I have a certain degree of confidence. I also know from 20 plus years experience teaching programming in front of students, never trust your programming skills when students are watching. That's when all the bugs are going to appear. I don't think I've ever written a program in front of students that worked. I've always introduced a bug. I've always had to fix it afterwards. It's just a rule of teaching this the subject. So I think the advantage is that if nothing else, they learn that everyone screws up coding. And I hope they do realize that because everyone screws up coding. It's just the nature of coding. So that's fine. But this time I didn't actually write it. It's the wrong one. Someone was telling me that earlier, weren't you? You were much better at this than me. Well, at least we can get that one running. Here's pressure info. I'll rebuild that one. Now we know one of them's working, then the other one should work. I'll let it run in the background and we'll come back to it. All right, so slides, so I don't waste all your time. All right, so things to do with it. So yesterday, a couple of weeks ago, actually, I thought this was a good statement. I was very proud of it when I wrote it, so you're stuck with it. Look, the thing is, an ESP32 has a bunch of inputs so that we can pull in anything. We can be pulling in data from whatever sensor you feel like. We can be pulling in data from over a whole stack of different formats. In turn, it's got a whole bunch of different ways it can then manipulate that data and send it out again. And things that it can control in the real world. If I want to hook a servo up to this thing, it is going to literally take me 2 minutes to get a servo running off it. If I want to hook up a stepper motor, which I might do for some reason or other, if I wanted to control the angle of something, again, it's going to take me maybe 5 minutes to get a working step. And I'm not making those numbers up because it does take 5 minutes to get a stepper motor running off it. There's really not a lot of work in it. I've got the ability from it to have input coming from almost anything. I have a whole stack of formats like Bluetooth and HTTP and all of these different wireless formats. If you imagine you've got that in a device that costs you about $10, you should start to be able to picture exactly why this is inherently cool in a really nice way. The sorts of things you can do with it are great. I find one of the things that I'm working with is that one of the big advantages of ESP32s is they talk to each other very well, which means it gives me a whole stack of low-cost distributed processing solutions when I'm building things. So I can have multiple of them working together rather than trying to get one massively powerful thing. I can have 10 ESP32s, each doing one little job but talking between them. And that's, again, trivial to set up. It's just where its strength is. I was thinking of jobs. So a little while ago, Jeremy gave me an SA828, which is a VHF radio transmitter receiver, correct? I'm hoping I'm doing all this right. I am rapidly learning because after he gave me that, I fell in love with it. I decided radio was the coolest thing ever right now. So it took me that to get there. But as soon as I got that, I realized, look what I can do with it. So I got it. I started running through it to see what I could do with the thing. Discovered that, firstly, it uses UART for communication. Secondly, somebody had published the entire API of everything I need to control it. And so at that point, I am set. You give me a basic system for communicating with it. You give me an API. The world is open. That's perfect. And so with an ESP32, the first thought I had, and it's probably a dumb one, is that I could get a touch screen and I can control it as a touchscreen-based walkie-talkie in, I would guess it would take me about a day to get that functioning. Now, in terms of the screen, the one I'm mentioning is a CYD. That's called a cheap yellow display in the ESP32 world. They look like this. It'll cost you about $15, maybe $20 if you go all out and buy it off Amazon. It's a ESP32 as per normal with everything they do, with a built-in LCD screen that's touch sensitive, but is trivial to code. Really very trivial to code. You can make it do whatever you like. It's also got a SD card reader built into it, so you can load up pictures and display it if you feel like doing something along those lines. And it's got, again, UART. It has SPI. I think it's got I2C. It doesn't have all the pins we would normally have because a lot of those pins are devoted to doing LCD screen and touchscreen. But be that as it may, and I've got one if anyone wants to look at it, for $15, you can hook this up to this SA828, and that's all I need to have with power in order to make something where I can have a full touchscreen walkie-talkie made for a grand total, based on my examination, to about $40 and about 60 cents at a 3D printed case. It's going to be nothing, so I've got to build it. I've got to build that really soon. If it wasn't for the fact I'm in the middle of marking, I would be doing that tomorrow. But if I don't get some assignments done by Monday, I'm in real trouble. So I'll probably do that over the weekend. Well, no, I say that now. Reality is Sunday I'm building this. Screw getting in trouble. I'm building this Sunday because it's just easy and joyous and simple to build. So other than that, once you get the SA828 as a simple thing and remembering we can control it and we can get all its inputs and outputs, I can control push to talk because it's simply a pin, and that makes it trivial to control it through an ESP32 pin. That's not a problem at all, just hook wire up. I can control volume if I wanted to. I can get the output from it directly into the ESP32 if I want to do that. So that opens up a whole stack of things that I can now do remotely because I've got a device for $15 that has built-in HTTP that I can use for communication over browsers if I want to, or whatever else I like. I can put it literally anywhere and start communicating with it without any hassles from anywhere. And again, we're talking maybe for something more complex, maybe a couple of days' work to build it, because most of your work is already done. The ESP32 is going to do the real work. There's going to be a bit of a coding problem. There always is. But it's going to be, and there's going to be bugs, but it's going to be manageable. By the way, let's just check to see whether this thing worked. Oh, yeah, looks like it may have. What I need to do is I just need to bring up the serial monitor so we can see what's happening. And there's all the data coming through. So temperature, I don't know what half these measured, air pressure, local airport sea level. I don't even know what they mean. I'm sure they mean something really cool. But I'm pulling data out of it immediately. And as you saw, that's the first time I've run that program, and it was 10 seconds to select it. Maybe a couple of minutes to find out the right library, copy it across, we're good. Yeah, I'm looking at it thinking, I thought we were above sea level, but to be honest, we've done nothing to try and set this up. I guarantee, but if we look at it properly and we look at the API, there's going to be things I was supposed to do. I'm just pulling out raw data without doing anything with that data. So I'm not surprised it's completely wrong, but I'm interested in the fact I'm getting data out of it in real time. But I do agree with you. It does seem to be a bit suspect in the numbers. 22 degrees, I don't know. Is that right? Could be. Yeah. Anyway, point is trivial. And that pressure sensor was $9 from JCar, and it would have been a lot cheaper if I hadn't gone to JCar. All right, last little bits, just very quickly. So I was running through other ideas. Dynamically programming, I really got caught up in the SA828. So it's just glorious, the little device. It would make me very happy. So yeah, there's a lot of things I can do with that from my understanding, my limited understanding of radio, which I hope to improve very soon. I've got a membership. What I've got to do is a foundation license. So I've been looking at doing it last couple of weeks. So I was hoping to sneak one in before I turned up so I wouldn't be completely ignorant. But I'm completely ignorant. I'm just like a student. Okay. So I was checking other options. So APRS, if you're into that, GPS module. I worked with a lot of GPS modules and ESP32s. The modules are questionable as to how reliable they are, but for about $40 to $50, you can actually get a pretty good GPS module at the moment. Hooking it into the ESP32 is trivial again because it's just going to be the right libraries and it's going to start giving you data. If I've got the right libraries, what it opens me up to is pretty cool. And again, we have a lot of memory to work with. We've got 2 cores, we've got decent performance. There's a lot you can do in there. So we're sort of getting the sensor data now, temperature and humidity and pressure. Okay, it's wrong, but it's pulling in data. So given that we're already pulling in that data, there's a whole stack of things we could do to transmit that to wherever we wanted. That would be trivial. A whole stack of things in terms of physical things we can control, relays. I use them to control robots, obviously, so this is my thing. But a whole stack of physical things we can control very easily over it, using anything from Bluetooth to radio to web, whatever you want to do for the controls. ESP Now, I'm actually interested in ESP Now for a mesh, so I'm going to do some work on that in the next few weeks because I'm curious about what we can do there. So there's a lot of things we can do on that one. So just to finish off, some quick issues for you. So the first bit is, as anybody who will tell you who's worked with it, the problem is you buy an ESP32 randomly from Amazon because you just picked one that looked like it was okay. You'll get it and discover the pins are completely different from the last one you got randomly from Amazon. So it takes a bit of time whenever you buy one to figure out what it is. What I'm starting to do now is buy the same brand every time in the hope that I'll get the consistency I desperately want. And I'm more or less getting it, so that's fine. But then there are different form factors as well. So the ones that I've shown you with a big lot of pins, they're great. But I can also get ones half that size with a completely different set of pins. So there's options around there, but it always takes a bit of time. And sometimes it'll burn you. I was working on a project recently. One of my ESP32s died. I panicked and thought, what am I going to do? I need it working by tomorrow or I'm in real trouble. I found I had a different ESP32. Every pin was different. It took me about 4 hours to rewire everything up because I had to reconnect it all. But, that's fine. You're not normally in that position. It's just annoying. All the boards, you've got to guess what the stupid configuration is. Hate that. Do that every time like I did then. I found out it was a Node MCU eventually and I knew what to do, but you don't know what it is most of the time. So you've got to go through this problem. The pins themselves, the number and locations, as I said, vary, but overall, phenomenally easy to work with, really easy to build stuff. If you haven't worked with them, the learning curve is nowhere near as bad as you think, especially if you've got any sort of programming background. I've used this to teach first years. I teach high school students who turn up and when desperately for a 1 hour session with me, and by the time we're finishing the session, they've got an ultrasonic getting readings and turning the lights on and off based on what the ultrasonic says. So this is really easy sort of code to work with. It doesn't take that long to pick it up. If you are like most of us, you are terrified of the phrase C++. I am. I'm a programmer and I'm always terrified of C++. Some of you may like it a lot, which I respect. I'm scared of you, but I respect it. But it's when you're programming in here, it's a much simplified, tidy version. Most of the time, you don't need to worry the same way, but I might with some of the other stuff I have to code in the language. So it's not that unapproachable. The sheer number of online tutorials is phenomenal. Okay, they're all different and half of them are wrong, but the number is phenomenal. And that's got to count for something, right? And just the price. I mean, when I discovered how cheap they were, that I could just go on. In fact, I'll show you because I was looking earlier today because I thought maybe I should order something. So if I still got it open, no, I don't have it open anymore. That's all right. I'll just get something open. This will do. So I just go to Amazon. So I want to build something with a touch screen using stuff from Amazon. So ESP32. So the first bit we're going to find is there's a whole bunch of them sitting around. I quite like these lonely binary 3-packs. I've been buying a lot of them. I don't know if they're any good, but they work. Here's 3 of them for $26, $27. That's all right. That's a lot of processing power for $26. So I'm not upset with that one. Here's the single one for 11. I'd get the 3. Mini, $20 for a little tiny form factor, for 2 in a little tiny form factor. Now, if I wanted to then toss in an LCD screen, touch screen with a built-in ESP32. If we're buying something like this, is effectively a cheap yellow display, except it's orange. It's going for $32. So then I don't need the ESP32 because it's already in there. So that's $32 for a touch screen with a built-in ESP32 ready to hook into anything I feel like hooking it into. Got to say that that is inherently appealing. I discovered these neat round ones lately. I've ordered a couple because they're round. I mean, there's an inherent joy in round LCDs, isn't there? Just inherent. It's built into the damn thing. And the one which I think Jeremy has been convinced is terrific is these little ones with a built-in screen into the ESP32 dev board to begin with. It's a tiny little screen, stupidly high resolution. I don't know what they're for other than they're glorious, but they are definitely glorious. So at some point I'll work out what we can do with them. But at the moment I just love them. There must be something they're useful for, right? But, you know, again, at $30 for one of them, I'll buy one. When Ruth isn't watching at home and I've had too much to drink again, but I'll buy one. So yeah, so it's an option. So anyway, so that's it. Sorry if I went over time, but you know I killed the computer, so I'll blame the computer. All right.
Thanks very much. Thank you very much, Adam. Just wonder if there's any questions from the floor. Ian.
Are there different flavors of this board you can get? You know,
Yeah,
different amounts of
that
memory or
they're going to be, there is variation in CPUs, and so there's some variation in performance and some of the configuration. So there'll be a bunch of them that are out. The latest ones are using a RISC-V CPU. And some of the older ones are still using the LX6 or the LX7. In general, you won't notice much of a difference unless you need that extra power from a particular configuration. It's just going to work. They're all dual core. They're all 32-bit. You're going to code them through the same interface. You're going to use the same libraries. I haven't needed to worry yet because my solution to lack of power is to add a second ESP32. And that just solves everything. So that's all I've been doing up till now. But yeah, there are variations. And there are certainly variations in form factor from the basic ones you saw, which are those little ones that look like a nano, if you know the Arduino nanos, through to the tiny little things, which are just tiny little square and just have no pins at all and just annoying but work, through to the other end, the ones built into screens and other devices by default. So, yep.
Just one quickly, not so much a question, but a statement. The ESP32s are magic. I have booted Linux on one, then run Go code to interface with the outside world from Linux on the ESP32.
Yeah, so you win. That's it, you just won. But you forgot to install Doom. It doesn't count to install Doom. Gotta do Doom.
What band does the ESP mesh use?
To be honest with you, I would need to check. I haven't played with it yet, so I don't know. Someone else might know.
But you said it can work at the same time as Wi-Fi?
Yeah, you can share it uses, all I know is it works, it plays well while still using Wi-Fi. I checked that today because I was curious about the problem, but I haven't worked with it yet, so I can't answer. Thank you. I knew Jeremy would know.
Just two questions. With the boards, do they have an external antenna connector on them?
Now I believe yes for some.
For some?
Yep, and I've read stuff about how to hook one up when they don't generally have one, but I haven't tried it yet. But
Right.
yes, I've been told you can.
Okay.
Yep.
Yep. And secondly, so I've developed a whole remote transmitter site based on the 8266. So I have 10 cards out there on 10 IP addresses with the web server, everything, and I'm just brilliant. But I buy them on a card that has 4, 2, 4, 8, 12, 16 relays on the card. So, you know, you can land them from Ali for about $15 for a 8-channel relay, and then you put your code on it and you have a little web engine, you press a button, it closes the relay. Really handy. Can you get similar things with the 32?
I so hope so. I really, really hope so, because now I'm just thinking what I can do with that.
Yeah, because you can. I mean,
I haven't looked, but I'm just so caught up in what I could do with that right now. But,
Yeah.
but I'm going home and I'm going to find out, because I will
Yeah.
order one.
So,
Ruth is going to be really
so-
angry at me, but I'm ordering one tonight.
so then to tie a big bow on that, of course, the 8266 is older.
Yep.
Now it has a little F antenna on it for 2.4 gigs if you look really carefully at the printed circuit board. So if you want to get that to an external antenna, so I have some of mine are 200 meters away from the access point. So you just get in there with a Stanley knife and you just cut off where it's going into the chip, where the transmitter comes out. The other side's earth. You put a piece of coax onto an SMA out to your Yagi, whatever you want to do, and they work absolutely perfectly. So you have to butcher the board ever so slightly, but that's why I asked about potentially a connector on it.
Yeah, I'd like to find out, because now I'm really curious.
Right. Excellent. Thank you.
We're good?
Oh, okay, Arthur.
And I will point out that those boards with the relays on them have got a very noisy switching regulator on there, which is bad for HF.
Yes, thank you, Art. They'd be very wary. So, as you said, they run from 5 volts, except they need 3.3 volts. And when I first ever made my remote site, it did have noise that just couldn't work out where it was coming from. This went on for a very long time. I didn't twig. And then Arthur, with his magic noise divining system, came out and we traced them down. The card has a little tiny little switch mode power supply on it. So every single receiver right next to one of these cards had a switch mode power supply right next to it. Anyway, they all got linearized and all my noise problems went away. So that is a very important point.
No problem.
Thanks very much, Steve. And Adam, thank you very much for a most interesting presentation. I hope everybody learned something this evening. Well, lots of nods.
If anyone,
Thank you very much.
Just mentioning, if anyone wants an ESP8266, I have a box. Yeah, yours.
$5 each.
No,
Club donation.
absolute waste to give me owning them, because I don't want to use them. I have this phobia of old tech. Actually, I'm lying. I love old tech, but I just always get the 32. So they've
Fair
just been
enough.
collecting by bad, and I want someone to
Okay.
use them, so I didn't waste the money.
Very
It'll
good,
make me
Adam.
happy.
Okay. Thank you very much, Adam. And just as a small token of appreciation,
Thank you.
there is a warning label on the bottle, all right? Do not go anywhere near Amazon
Yep.
when the bottle's open.
Fair enough. I will stick to that.
Thank you very much, Adam.